Hi class, today our first lesson for semester 1 will be on from chapter 1, which is physical quantities and SI unit. Class by Raj, teaching for form 6 physics semester 1. There are two major systems of unit used in the world: SI unit or International System of Unit, or commonly known as the metric system, and the other unit is English unit, also known as the imperial system. English unit were historically used in nations once ruled by the British Empire. Today, the United States is the only country that still uses English unit extensively. Virtually every other country in the world now uses the metric system, which is the standard system agreed upon by scientists and mathematicians. There are two type of quantities, and they are physical quantities and non-physical quantities. A physical quantity is a property of a material or a system that can be measured. Example, mass, time, length. A physical quantity has a numerical value and a measurement unit. We can represent a physical quantity by the symbol of the quantity, the numerical value, and a measurement unit. Example, M. M is a mass, and mass is a physical quantity. Here we represent mass with a numerical value and a measurement unit, which is kilogram. The learning outcome for today's class is to list base quantity: mass, length, time, current, temperature, and quantity of matter. There are two types of physical quantities. That is base quantity, or sometimes it is called as fundamental quantity, and derived quantity. Base quantity are physical quantities that cannot be defined in terms of other quantities. When you were in Form 5, you studied 5 basic quantities. They are mass, time, length, temperature, and electric current. Kilogram, second, meter, Kelvin, ampere are called as base unit. In the symbol of a base unit, you will realize that kilogram, second, and meter are in small letters, but capital K, which is Kelvin, is in capital letter. It is because William Thomson, known as Lord Kelvin, was one of the most eminent scientists of the 19th century and is best known for inventing the international system of absolute temperature that bears his name. Whereas the symbol for base unit is capital A. The unit ampere for the electric current, named after the French physicist Andrea-Marie Ampere, is one of the 7 traditional basic units in the International System of Unit. In Form 6, you will be adding another basic quantities, which is called as amount of substance. The base unit for the amount of substance is mole, and the symbol is MOL, mole. But actually, class, the total number of basic quantities are 7. The other basic quantities are called as luminous intensity, where unit is candela and the symbol of the unit is CD. Our next learning outcome will be to deduce the unit for derived quantities. A derived quantity is a quantity in a system of quantities that is defined in terms of only the base quantities of the system. When converting the unit of a derived quantity, each of its base unit involved must be converted. Example of derived quantity is speed, acceleration, density, momentum. Homeworks will be given to test you on how to derive quantities. Prefix. Prefixes are used to simplify the description of physical quantities that are either very big or very small in SI unit. A metric prefix or SI prefix is a unit prefix that precedes a basic unit of measurement to indicate a multiple or fraction of the unit. Each prefix has a unique symbol. Example, tera, the symbol is T. Mega, the symbol is capital M. You have to know your prefix. A prefix is usually stated in between a numerical value and a measurement unit. Example, here physical quantity is length and numerical value is 20. Measurement unit is M, but the prefix is milli, small m. In Form 6, you need to know the dimension of physical quantities. There are 5 basic physical quantities that you have studied in your Form 5, which is mass, time, length, temperature, and electric current. And you add up another basic quantity, which is the amount of substance. And you are aware there are total 7 together. Dimension is very important and it will be taught in the next lesson. But you have to know the dimension of the basic physical quantities in this lesson. The dimension of mass is capital M. The dimension of time is capital T. The dimension of length is capital L. And the dimension of temperature is theta. And the dimension of electric current is I. And the dimension of amount of substance is capital N. Now, what is dimension, class? Dimension is the power of which fundamental unit are raised in order to obtain the unit of a physical quantity, and these are called dimension of that physical quantities. Dimension of physical quantities does not depend on the system of unit.
Today we are going to look at the dimension of physical quantities. As I've already taught you, the 5 or the 6 physical quantities that you should know their dimension is mass, okay, mass, the dimension is m, and then we have length, okay, the dimension is capital L, and then we have time, the dimension is capital T, and then electric current, dimension is capital I, temperature, theta, and then we have the last, amount of matter or substance, the dimension is capital N. So these are dimension, class. So we have studied in our previous lesson. So today we are going to do is we're going to figure out how to use this dimension in derived quantity. Okay, so this is a dimension for basic quantities. Okay, so dimension for derived quantity will be like, say for example, if I want to find a speed, dimension for speed. Now we know speed is distance over time. Now this is called as a formula. Okay, this one is called as a formula, or we can say is an formula lah. Okay, now most of the time the formula taken for derivation of dimension is by looking at the derivation of the quantity. Okay, Alright, so here speed is distance over time. If the next process is the process of dimension, what I have to do is the symbol for the dimension of physical quantity is written as like this. So when I write like this, then I know that I want to do is a dimension process. Is my next step, distance over time. Okay, I even can do separately. I even can do like this if I want to, distance or over time, separately a physical quantity. Okay, I can even do that if I want to. So in this case, when I see this kind of bracket, I know this is already a dimension to figure out or to find the dimension of speed. So next is when you do that, you do speed with the bracket, and then okay, the distance is a sort of quantity that is from length. Okay, so we put L. Time is T, so we put T. So the dimension for speed is L T negative 1. So this is how to find dimension. Okay, now I give you another example. Instead of writing the formula in words, I can also write the formula in symbol. Okay, like next, I want to find the dimension of acceleration. Okay, I want to find the dimension for acceleration. Now, from a derivation, okay, from a definition, I will know that acceleration A is equals to V over T. Okay, from the definition. So that means if I want my next process, I want to go for dimension, what I do is I put a bracket. Okay, so then therefore I will get the dimension of A, which is the dimension of acceleration, is the dimension of V. I can also write in this way if I want to. Okay, V over T. Okay, so therefore the dimension of V is L, and the dimension of V is L from here. Okay, L T negative 1 divided by T. So I get L T negative 2. So the dimension of acceleration is L T negative 2. Okay, alright, so I'm going to give you another example. Okay, maybe we want to find is the dimension of force. Okay, force. From the definition, okay, of Newton's second law and interpretation, we know F equals to ma. So if I want to find the dimension of this force, so dimension of force, you write it in such a way. Okay, you can also write it like that. Okay, so what is the dimension of m? M is mass, so dimension of m is capital M. Dimension of A is L T negative 2. So dimension of force is M L T negative 2. So this is how to find dimension. Now dimension has many use. Why we need to study dimension is because dimension has many uses. Alright, so we will go on with the next lesson later on how to what is the uses of dimension or dimension analysis. Okay, alright, so thank you class.